Space itself is not cold or hot, because temperature has no meaning without a substance with thermal changes. Since there is an ultimate limit to cold, which is absolute zero or minus 273.15 degrees Celsius, it is impossible for anything to get colder than this temperature. But when we talk about the theoretical maximum temperature, the matter is slightly different. Join us to learn about the coldest and hottest regions known. Boomerang nebula gases have formed the center of the cosmic region, the coldest region in the universe. The coldest temperature that can be reached according to the laws of physics is absolute zero, or minus 273.15 degrees Celsius in scientific experiments. Scientists have reached temperatures up to a billionth of a degree above absolute zero, but complex and expensive equipment is needed to reach these incredible temperatures. But in the universe, the coldest known natural places are the gases of the Boomerang Nebula, which have a cold temperature of minus 272.1 degrees Celsius. This nebula, which is 5,000 light-years away from the Earth, is located in the constellation of Centaurus and was formed from the death of a star whose expansion of nebula gases caused its temperature to cool to 1 degree above absolute zero. In 2013, a group of researchers announced that they have created a quantum gas consisting of potassium atoms, which has a negative temperature. Although this negative temperature condition is more of a thermodynamic interpretation and is related to states where the entropy of matter has increased to the maximum, and with a further increase, entropy decreases. But the hottest point in the universe goes back to the heart of the Big Bang, the compressed point of temperature and density where our universe began, called the Planck temperature. Based on our current understanding of the physics of the universe, this temperature is equivalent to a supertemperature of Kelvin. This temperature is the highest temperature allowed in the standard model of particle physics. According to scientists, this temperature occurs only when the particles interact with each other and reach thermal equilibrium. To imagine such a temperature and reach its meaning, you must know the concept of balance. Many cosmologists believe that the actual hottest temperature in the history of the universe is several orders of magnitude cooler than the Planck temperature. Based on studies, cosmologists say that in the first moments after the Big Bang, the expansion of the universe was done so fast that no particles were able to interact. And in those moments the world necessarily had a very low temperature. In a small fraction of a second after this event, the space-time microwaves may have started vibrating with the matter and forced the matter to thermal equilibrium. This has caused the rapid reheating of the world to a temperature equivalent to 10 to the power of 27 Kelvin.